In one categorical variable, we have a few graphical displays that we can use, one of which we have over here, which we will of course recognize as a pie chart. We're going to look at diamond clarity, which is categorical. We have a lot of grades of diamonds, and down here at the bottom we can start with the lowest grade, which is I3. That I stands for the word inclusions. Inclusions are these little imperfections like nicks and scratches in the diamond. They could be on the outside or on the inside. So we have I1, 2, and 3, and then when we get up to SI, this is slight inclusions. So they're noticeable, but they're not huge, right? So S stands for slight inclusions. VS stands for very slight. So we get into very slight, and then yes, you may have guessed, very, very slight is our VVS. So we're increasing in clarity as we go up. IF stands for internally flawless. That one actually has the same initials that we see over here in our description. And FL stands for flawless. These are our highest clarity level of diamond. So now that we have some idea what we're talking about with diamonds and what these abbreviations stand for, we can look at these two graphical displays. We have a pie chart on the left and a bar chart on the right. These bar charts can be oriented vertically or horizontally. And this has count, which is also sometimes called frequency. So if we see frequency over there, that means the same thing as count. So based on these graphs, which is the most common clarity is our first question. That's the one that has the most in it. This is our tallest bar. Or if we are looking at our pie chart, we can see that this orange region looks like it's the biggest, and our orange is VS1. That bar is also VS1, so it looks like VS1 is how we would answer this. The bar chart was probably slightly easier to look at, to read, because we can really let that tallest bar stand out, but the pie chart was not very difficult. All right, so for the least common clarity, we now have the shortest bar, at least the least common clarity that does show up in our sample. I think I noticed at some point we don't have any pure flawless diamonds in this sample. I don't see any FL, but we're going to ignore that for now and say the least common of those that are represented at all. The shortest bar is pretty easy to pick out. The smallest slice of this pie we can pick out, but its color is the hardest to really see well because it's so small. Either way, we can see that that would be SI3. So both of these questions were pretty reasonable to answer based on either graph. Which is more common, VVS1 or VVS2? I can compare the heights of these two bars. Or over here on the pie chart, I now have to make sure I'm looking at the right colors. We have a pale yellow and we have a dark yellow. This here is our pale yellow, so this is my VVS2. And my sort of more terracotta kind of red instead of brick red is my VVS1. Now this is looking pretty difficult, comparing these two areas. First of all, even identifying them correctly by color. Second of all, comparing the two areas, I can sort of tell that that VVS2 wedge is slightly bigger, but looking at the bar chart, it's obvious, right? It's obvious that this bar is taller. So VVS2, we're starting to really care which display we look at to get these answers now, right? And which is more common, internally flawless or slightly included 2. Again, the bar chart's probably easier to look at here. The labels are right next to the bars, and bar heights are a lot easier to compare than wedge areas. So more common, let's go with IF. So even though we can use a pie chart or a bar chart to display data for one categorical variable, the bar chart really is better. It's easier to read. And it's easier to read partly because it doesn't rely on any color coding, right? Colors work for some of us, but not so well for others. And even those of us who can see colors just fine, if we have lots and lots of categories, we're going to have some colors that are very close to each other. There's no avoiding it. And bar heights are just easier to compare. It's a one-dimensional measure, right? These are really one-dimensional when we're comparing the measures. So we have one-dimensional comparisons. This is more natural for humans. We're not very good at looking at two areas and determining which one is bigger. In addition to looking at graphical displays, we also summarize one categorical variable with proportions. If we're talking about the proportion for a sample, then we call that proportion p hat, which when we talk about it, we pronounce p hat. It's wearing a cute little hat, right? When we're talking about the proportion for a whole population, we would call it just p. In this case, we're talking about a sample of diamonds. So of course, when we write down this proportion, where it says to write it using correct notation, that means we need to determine whether we should be using p or p hat. So the correct notation in this case is p hat because we're talking about a sample. So I'm going to start with p hat equals, and then think about the details of calculating this proportion. We're asked to find the proportion of diamonds in this sample, so that means we're calculating a proportion of all of the diamonds in the sample, which is 351. This is going to be relevant to part of our calculation, that are internally flawless. So the internally flawless is also going to be part of our calculation. This is how we figure out what two numbers we're going to divide. So to find p hat, we're going to take the number that are internally flawless and divide it by the total number in our sample and get a decimal number. So bringing up my calculator here, 16 divided by 351 gives me 0.04558. Let's go ahead and round that to 0.046. And if we wanted to express that as a percent, we weren't asked for a percent, we were just asked for a proportion. But if we wanted to express that as a percent, we would move the decimal point 2 places to the right. So that I would write that as 4.6%. Be sure to look at the instructions to see whether you're asked for a proportion or a percent. Also, think about the number of decimal places. If we were asked for a proportion to 3 decimal places, this would be our first answer. But by the time we convert it to a percent, we can see that only has 1 decimal place. So in your planning for how many decimal places to track, if your ultimate goal is a percent, take it out to 2 more decimal places as a proportion than what is indicated in the instructions.